All right, functions, we are going to start with solving. We're going to solve rational equations. So the biggest thing is we're going to be adding and subtracting fractions, but they're going to be equal to another fraction. So we're going to be using these strategies only when there's an equal sign present. So one of the things is that we are going to want to determine the domain of the variables for each of those rationals. So the way that we would find the domain is first we'd find that LCD. So go ahead and find the LCD, hit pause, and find the LCD of this. Okay, so the LCD, the least common denominator, is going to be everything in this denominator, so I have an x, everything in this one, so times 4, and this one already has a 4x, so that's going to be my LCD. So my domain is going to be all real numbers such that x cannot equal 0, because the value of x here that would make this whole thing 0 is 0. All right, I'm going to hit enter, and there's going to be a lot of words. But what I want you to take away from this is that this in your homework is what they want, is that set notation. So we're going to have all values of x such that x cannot equal 0. So in your homework, you would be entering this part, the variable and what it can't equal. That's all you'll be entering. But it also just means the same thing. So when we're looking at this problem, what we want to do first is we want to factor this. So this is going to be x plus 2, x minus 2. And then we want to find the LCD with all three of those. So again, the LCD is going to be everything that's in the first one, x plus 2, x minus 2. Everything that's in the second one that isn't already written down, we already have that. And I already have that, so I don't need to write it. So then my domain is going to be all real numbers such that x cannot equal plus or minus 2. Because a positive 2 or a negative 2 here would make this 0, and a positive 2 there would make that a 0. So again, we're going to have it this way. You can use the plus or minus sign, or you could write 2, negative 2 with a comma, or like this. Either way. So I have it written here without the plus or minus. All right. So the easiest way to solve most rational equations is to multiply all the terms by the least common denominator. So we've been finding the least common denominator for a long time now. Now we're going to use it to help us solve. It's going to help us get the denominators out. So one of the things that we could say is, like, you guys have probably seen problems, I don't know, 1 over 9x, okay? How we would get that, we would want to get that out of the denominator by multiplying by 9x, and then we'd multiply everything over here by 9x. Okay, so the least common denominator with this would be 9x. So you have been doing this stuff. We're just going to do it where it's a little bit more complicated because we have more fractions. All right, the biggest caveat, all of this says, check your answer. Check your answer. Make sure the answers that you find actually work. So you're going to want to plug that in because we're going to be looking for something called an extraneous solution, meaning it's an answer, it's just not an answer that works. So this is where it gets weird on my PowerPoint. All right, so I need you to write this down. We're going to start by finding the LCD. So the first thing I'm going to do, also we want to see this negative. We never want a negative in the denominator. So I'm going to take this negative and I'm going to throw it out front and make this a negative 3. That is the same thing. That's just going to help me later on. So my LCD for this, well, I've got a 20. That's everything in the first one. This one has an x, so I'm going to do times x. And then I have an x here, so I don't need to write it again, but that 4, do I need to put the 4? No, I could just say, what is the least common multiple between 20 and 4? The least common multiple, meaning what is the smallest number 4 and 20 both multiply to? And that would be 20. So I could multiply top and bottom by 5 to get that common denominator. So I'm going to leave it as 20x. Then my domain is going to be all real numbers such that x cannot equal 0. All right, now I'm going to multiply the entire thing by the least common denominator of 20x. So that means I'm going to multiply 20x times this. Let's see. Yeah. So by every single fraction. Again, I'm going to move this minus sign to right here. So I'm just moving it up so that I'm going to multiply. Now what I'm going to do, and really this could be all over 1, all over 1, all over 1, and then I'm looking for big ones. Now I have a multiplication problem. 3 little multiplication problems. So if I'm looking at this, do I have a big one here? I do. I have a big one here and here. So then I get negative 3 times x over 1 times 1. Negative 3 times x, this is y, over 1. But do I really need that over 1? No, not really. So I'm not going to write it. I'm going to erase it real quick because I don't want it, because I don't need it. All right, let's see if I can. Oops. And then I want to keep writing. Okay, so then I have a big one right here. This x and this x turns into a 1, and I end up with 20 times 2 over 1, and 20 times 2 over 1 is 40. Then I have, so this one's a little bit weird because I have this x, but I also have a 20 over 4, or I could do 20 times 5, which is 100, divided by 4. 20 times 5 divided by 4 is 25. Or I could say 20 divided by 4 is 5, and 5 times 5 is 25. Either way, it doesn't matter. You end up with 25. Okay, so make sure that you understand what I did there. Go ahead and we're going to go to the... So now that I've gotten rid of everything in the denominator, now all I have is negative 3 plus 40 equals 25. Well, this is just a linear equation. I know how to solve that. I'm going to subtract 40 from both sides, and then, let's see if I can get this to work, 40 from both sides. I end up with negative 3x equals negative 15. Divide negative 3 by both sides. I end up with x equals 5. All right, x equals 5. So now the last thing I have to do is check my answer. So that's a proposed solution. It could be a solution, and it might not be. So everywhere I see an x, I'm going to replace it with a 5. I have to have common denominator of 20, so I'm going to need to multiply top and bottom right here by 4 so that I can get 20. And I end up with negative 3 over 20 plus, okay, here we go. Negative 3 over 20 plus 8 over 20 equals 5 over 20. Well, negative 3 plus 5 does equal 5 over 20, and that is true. So then the solution set for this particular one is just 5. 5 is the answer, and it works. All right, now let's try this one. Again, the first thing we want to do is find our LCD, but we need to factor this. This is a difference of squares. That's a 1. And we end up with my LCD is x plus 1 and x minus 1, and my domain is all real numbers such that x cannot equal plus or minus 1. So here's another way that you could see that. All right, so now I'm going to multiply. This is what I was talking about, where you could put everything over 1. So now I've got this is that part, then I've got this, which is this part, and then I have this, which is this part. So what I'm going to start doing is I'm going to find my big ones, because it's this times this, and actually this should have parentheses, sorry. I forgot that I didn't type them in, and I had to write them in all day. Now we can start looking for our big one. So I have an x plus 1 and an x plus 1, so this turns into a 1 right here. And so then I'm left with 1 times x minus 1 times 3. Well, 3 times x minus 1 all over 1 times 1, which is just 3 times x is 3x. 3 times negative 1 is negative 3. Okay, here, then I have this equal sign. This equal sign stays with the problem. My arrow is looking terrible, but it's there. So I'm going to put equals. And then I'm going to find a big one here. So there's a 1 right here. Then I just have 1 times x plus 1, which is just x plus 1, over 1 times 1, which is 1. Then the minus sign stays with it. I have minus. And then I have an x plus 1 right here, x plus 1, x plus 1. Then I have an x minus 1, x minus 1. So then I just have 1 times 2 over 1, which is 2. Now I'm just going to combine my like terms. So go ahead and do that. Combine your like terms, and then we're going to go to the next step. So I have it typed out so that if I didn't distribute the 3, this is what it would look like. 3 times x minus 1. So then when you combine your like terms, you get 1 minus 2, and you get x minus 1. then you are going to add 3 to both sides. So we end up with 3, add 3 to both sides, and then we subtract an x, and we get 2x equals that, and so we end up with x equals 1. Now we have to check our answer. You have to check your, oops, I don't know why I put answer. Always. So, if we plug in 1, it says since the proposed solution is not in the domain, so notice that we said x cannot equal 1 or negative 1, and we got positive 1 as a solution, we want to make sure we plug it into the equation to find out why. So, I'm going to replace all of the x's with a 1. I end up with 1 plus 1, 1 minus 1. I end up 3 over 2 equals 1 over 0 minus 2 over 0. We can never have 0 in the denominator. Friends, don't let friends divide by 0. Not okay. So, since that is a division by 0 is undefined, the equation has no solution, so the solution set is the null set. So it would be this little circle with a line through it. So that is what you would put, or no solution. In your homework, I think it's looking for this symbol. If you have any questions, please come to class with those questions. We're going to do a couple more examples that are different, and then we are going to be ready to take this test on Tuesday, December 21st. All right, have a great day. See you all tomorrow.